When you leave your local area and fly cross-country, you have a choice of using one of several forms of navigation. In this program, we'll look at two of these, pilotage and dead reckoning. When you use pilotage to fly a predetermined course, you'll identify features on the ground by comparing them to symbols on an aeronautical chart. The recommended chart to use for cross-country flights is a sectional, since it provides more detail than other types of charts. Always use a current chart for flight planning and navigation. An out-of-date chart may give you incorrect information. The altitude you select is also important when you need to identify landmarks. If you're too high, detail is lost, and some checkpoints may appear too small to be positively identified. Flying too low not only gives you a poor perspective, but may restrict your visibility, especially when haze and smoke are present. The key to pilotage is selecting reference points along your route that are easy to identify from the air. Let's look at some examples. Lines that intersect or that form unusual angles are good checkpoints. Here, the jog in the road just before the intersection makes it easier to identify from the air. When you identify a checkpoint, use more than one feature. Here, the town of Windsor can be identified by the angles formed by the road and railroads to the east. In addition, there's a lake to the north and a tower to the south. When you combine all of these items, your identification of the checkpoint becomes much easier than if only one feature is used. As you gain experience, maintaining orientation by reference to landmarks will become second nature. Taking the time to adequately plan your flight will help you maintain orientation over unfamiliar or featureless terrain. When you combine your pilotage skills with dead reckoning, you have a very precise form of navigation. As with pilotage, preparation for dead reckoning navigation begins prior to flight, when you use time, speed, distance, and direction to predict the movement of your aircraft along the planned route. Thorough pre-flight planning is the key to a successful cross-country flight. You'll usually begin with an analysis of the route. In this step, you'll determine the true course, measure the distance, and select prominent checkpoints. To find the true course, you'll use a navigation plotter similar to this one. It has three basic components: a straight edge to draw the course line, a protractor to determine the direction of the course, and mileage scales to measure distance. To help demonstrate the use of the plotter, we'll use this simplified rendition of a sectional chart. The departure airport in this example is McGee, and the destination is Waynesboro. The straight edge portion of the plotter is used to draw a line connecting the two airports. This is what's referred to as a direct route. To measure the true course, select the line of longitude that's close to the midpoint of the route. Then align the straight edge with your route and place the small hole over the longitude line. Read the true course where the line of longitude crosses the protractor. Use the scale with the arrow pointing in your direction of travel. In this example, the true course is 102 degrees. The outer scale on the protractor represents easterly courses, and the inner scale represents westerly courses. If your course does not cross a line of longitude, you can use a line of latitude for the measurement. The small north-south scales are used instead of the larger east-west scales. In this example, the true course is 30 degrees. Another function of the plotter is to measure distances. Most VFR plotters have mileage scales that match WAC charts, as well as sectional charts. This plotter also has a scale to be used on terminal area charts. Always use the scale appropriate to the chart you're using. Both nautical and statute mile distances can be determined with the plotter. Let's look at how to measure the mileage for the sample flight. To measure the distance from McGee to Waynesboro, place the zero end of the plotter over the departure airport and align the straight edge with the course line. In this example, the nautical mile scale is used. The distance to the destination airport is 60 nautical miles. Now that the course is plotted and measured, return to the actual chart and select checkpoints that will help you identify the course during the flight. The number of checkpoints you select depends on the length and complexity of the flight, as well as the terrain you're flying over. Each checkpoint should be clearly marked on the sectional chart and entered on a navigation log. This log is an excellent tool for organizing all of the data about the flight. The information recorded so far includes the checkpoints, the route, which in this case is direct, the total distance, and the true course. The analysis of the route should also include measuring the distances between each checkpoint. The next planning step is to analyze the effects of wind. Here you need to determine the wind speed and direction and the true air speed. With this information you can find true heading and ground speed. You can obtain the wind information during your normal pre-flight weather briefing with the flight service station.
Wind and temperature at 3,000 are forecast to be 240 at 16 and temperature 23. At 6,000, 230 at 20, temperature 17.
The analysis of the winds aloft will usually reveal the most favorable cruising altitude. The altitude you choose should comply with the VFR cruising altitude specified in the FARs. The altitude is also important for determining the true airspeed for the flight. This airspeed may be found in the pilot's operating handbook or by using the flight computer. With the wind, true airspeed, and true course known, you can use the flight computer to find true heading and ground speed. To compute these values, you'll use the same procedures as described in the program on flight computers. To conclude the direction calculations, convert your true values to magnetic by adjusting for variation and deviation. Lines of variation are printed on sectional charts and are labeled in degrees west or east. When you apply variation to the true heading, westerly values are added and easterly values are subtracted. This line represents 2 degrees easterly variation. Therefore, you will subtract it from the true heading of 107 degrees to get a magnetic heading of 105 degrees. A good memory aid on whether to add or subtract variations is east is least and west is best. Now you are ready to adjust the magnetic heading for deviation by compensating for the instrument and installation errors in the magnetic compass. This card tells you what heading you should steer for a particular magnetic heading. The magnetic heading for this flight, 105 degrees, falls between east and 120 degrees. Since neither of these headings require a correction, the compass heading will be the same as the magnetic heading. As a final step in the route planning, compute the time and fuel requirements for the flight. These are basic time, speed, and distance calculations to find the estimated time en route, ETE, between checkpoints and the total estimated time for the complete trip. The fuel requirement should also include the reserve required by the regulations. Spaces are provided on the navigation log to record pertinent information about departure and destination airports. The sources of this information will be covered in the next program. A flight plan form is also included on the reverse side of the navigation log. This form contains spaces for you to list pertinent information about your flight. When you have completed the form, you should file the flight plan by calling the nearest flight service station.
I'd like to file a VFR flight plan.
Go ahead.
The aircraft is 52241, a Cessna 172/uniform. True airspeed 112 knots. Departure point is McGee. Proposed departure time 1600 Zulu. Altitude 3,500. Route is McGee, direct Waynesboro. Destination Waynesboro. ETE 31 minutes. Fuel on board 3 hours 40 minutes. And the pilot's name is Fred Adams. 1114 Fox.
If you anticipate a delay in your departure in excess of 1 hour, let the flight service station know. If you do not, the flight plan is considered void after an hour, and you must refile. One of the most satisfying aspects of learning to fly comes from completing a well-planned cross-country flight. As you gain experience, you will find that the fundamentals learned during pilotage and dead reckoning can be applied to most other forms of navigation.